All right, so we're solving exponential equations. So hopefully you've seen exponents before. I didn't make videos for the beginning and intermediate algebra stuff because you did take it somewhere, but I gave you videos that someone else had made so you can quick review just the bits that we need. There's no homework on that, so this is where the class really starts, the official start of the class. All right, and this is 2 to the power x equals 32, and I'm trying to figure out what x would be. Okay, and you could maybe count it off on your fingers, but I'm just trying to get the other side to look the same. 32. 32 definitely has something to do with 2 because it's even. Well, 32, let's see, that's 2 times 16, that's 2 times 8, 2 times 4, 2 times 2. So that's actually 2 to the 5th. 1, 2, 3, 4, 5. Okay, and now why I'm calling this erase the base is because if I want to solve this, I mean, I can kind of look at it and tell, but I could just erase the bases off here. If I erase that 2 and erase that 2, now it just says x equals 5, and I have the answer. So that's how to do that. All of these problems that I'm going over are written in the notes part of it. You don't have to hand me the notes, just the homework page. 16 to the x, 8 to the x plus 1. Okay, and I'd like to do the same thing. And the problem is that I can't figure out, I mean, I know that 8 goes in to 16, but it doesn't it's not a power thing. It's not like 8 squared because that's 64. So instead of trying to use the base 8, which is what I first think is maybe if I can get them both to be 8s, that would work. I'm going to try going back to the base 2. 8 is 2 times 4, and that's 2 times 2. So 8 is 2 to the 3. So I've just replaced the 8 with the 2 to the 3, and the x plus 1 is still up there. I haven't done anything with that. And 16 okay, so that's 2 to the 4. All right, now you stop thinking about the exponent like it's sort of attached to the 2, and think about this 4 like it's more attached to the x. A power to a power, you multiply powers, so 4 times x is 4x. So really this just says 2 to the 4x. Okay, I'm no longer thinking about it like it needs to live with this 2 for the rest of its life. It's going over there to be with the x. Same thing here. Okay, I'm going to make this 3 live with the x and the plus 1. So distributive property, 3 times x, 3x, 3 times 1, 3. Now I'm ready for erase the base. So 4x equals 3x plus 3. X equals 3. All right, one more with a different base so that we just get used to the fact there could be different bases. Nine to the x, 27 to the x minus 1. All right, so 9, that's 3 times 3. That's 3 squared. And 27 is 9 times 3, so it's 3 times 3 times 3. So that's 3 to the 3. Now make the exponent live with the other exponent, power to a power, multiply powers, so that's 3 to the 2x. This is 3 to the 3x minus 3. Erase the base, 2x equals 3x minus 3. All right, so negative x equals negative 3 x equals 3. All right, so that's how to do those problems. Now what happens eventually is someone gives you a problem like this. 5 to the x equals 7 to the 2x. Now try as I might, I can't think of anything the 5 and 7 have in common. I can't turn 5 into like 2 times 2 times 2 or 3 times 3 times 3 or anything like that. Same thing with 7. And even if somehow or other there was some obvious number everyone else can think of, but I just can't, we need another method for when there's just no way. Those two numbers, 5 and 7, I'm not going to be able to get and erase the base on those. And that's why we need logarithms. Okay, logarithms are a thing to get stuff down from the exponent. So the next video, we got to start in on logarithms just so we can be able to solve this problem.